All right, class. So this is for worksheet 12.5a. Okay, and this is going to be just part one. So I'm going to break this up into two short videos. So this first part is just kind of an overview of trying to understand planes. So that's kind of a key thing that we're going to get into is talking about planes. So first off, let's talk about write an equation for a plane, and make sure to really fully understand the difference between that and versus a line, and looking at the slopes here. So if, first off, understanding that if we're looking for a plane, and let's look at a couple of them here. Let's say these planes are like this. Okay, so if I draw a line through them, okay, how are they represented? Well, the equation is in standard form, which would be like something like ax plus by plus cz equals d. Okay, that this line here is the normal, or sometimes referred to as perpendicular or orthogonal, plural form. All means they are perpendicular. So, whoops, what happened there? Perpendicular, perpendicular. So this, the norm, is the slope of A, B, and C. Okay. Now, if I'm looking for, so that's the equation of this. Now, if I was looking for the equation of the line, RT, okay, then I use the same slope here, A, B, C, T, plus a point, X, comma, Y, comma, Z, let's say. Actually, let's say A, B, C. Let's do that way. It's something, let's just say 1, 2, 3. There we go. All right. All right, so there's a difference between the two. So that would mean then if I had three non-collinear points, to say point here, point here, point here. Let's see a different color here. These 3 points here, or let's say these 3 points here, and these 3 points here. If I use these 3 points here and did the cross product, that would give me the slope of that. Okay. And then, the only difference is the d here. Okay. So how would I find the d? Well, the easiest way is just take, let's say, one of these points. Let's say this point here, and I just do the dot product of that, or take a point here, dot product, and therefore what you'd get, let's say, as an example, let's say if you have 2x plus 3y equal, or plus 4z equals, let's say 5, that might be this one here. Or you have 2x plus 3y plus 4z equals negative, let's say 2 here. That might be this one. 2x plus 3y plus 4z equals 0. Maybe this one. Now this one here would be the only one that's actually going through the origin. These here just represent a certain distance, but not necessarily distance from the origin, just a certain length somehow. Okay. All right. But the slope here, 2, 3, 4, is the slope of this here. Okay. So it's not the plane itself, it's the orthogonal vector of the plane. But if I wanted to write the equation of the line, So if I RT, I'd use 2, 3, 4 for the equation of the line. Okay. So what we're working on is in terms of things intersecting, lines and planes. So you have to really understand the difference between the line and the plane in terms of finding certain things here. All right, so let's do an example here. Okay, so let's say write an equation of the plane. Okay, so that would mean we need like ax plus by plus cz equals d. So we need the orthogonal vector. So if I give you the norm, okay, so you have, let's say, 2, 3, 4, and 1 point on the plane. Okay, so let's say 2, 4, negative 1. Okay, so therefore, what's the equation? Well, this is so here's my plane. This is that. Okay, that's the slope. So therefore, it would be 2x plus 3y plus 4z equals d. Now, there's a couple ways you can get d. I told you about the easiest way is just take any point and do the dot product. So 2, 3, 4, dot 2, 4, negative 1. And just think of it in that way. Even if, yes, it's not the same, but you get the same values quickly. So you have 4 plus 12 minus 4. So therefore D is that. There's a thing called partials. If you looked at the book, I know some of you looked at that and did it by partials. By using shift laws is basically what it is. But dot product gives you the same value much quicker. So therefore you have 2x plus 3y plus 4z equals 12. Okay? All right. So if let's change the directions a little bit. Okay. Find the plane parallel to, say, 2x plus y plus 3z equals 4, and the plane, it goes through the point 1, 1, negative 1. Okay. So remember I mentioned planes being parallel. This will be the slope of 2, 1, 3. So therefore, yes, this might represent this plane here, but I gave you a point in another plane, so all you have to do is take your slope 2, 1, 3, dot it with any other point that you want to use here. So you have 2 plus 1 minus 3, so it looks like 0. So the equation of this plane, using this value here, you have just 2x plus y plus 3z equals 0. And since this is 0, I know it goes through the origin. Okay. All right. All right. Let's change up one more thing here. Okay, so let's say passes. So this is talking about planes now. Still passes through the point of 3, 2, 1, and parallel to the plane of y equals 4, which means then, if this is the plane here, This is actually 0x plus 1y plus 0z equals 4. So if we draw this out, just to kind of visualize this, there's my x-axis, my y, my z. So therefore, if I have y equals 4, and this is 0, 0, you have 1, 2, 3, 4. Here's the equation of the plane. Like so. So therefore, what is the slope of this? Well, my slope is 0, 1, 0 is my slope. And then whatever this point, which I couldn't redraw, there's 3, 2, 1. Now I'm not going to try to draw it. So if I just dot it with 3, 2, 1, I have 0 plus 2 plus 0, so 2. Therefore, my new plane is now going to be y equals 2. And let's see if I can draw that one here. So here's y equals 2. So I'm drawing that out. And there's that. And likewise, if I want to do another one parallel, much quicker, let's say y equals 6. That's too much the same here. Let's see, orange. So like, for example, here, that plane there would be y equals 6. All parallel with the same slope of this. All right. Now, if you want to look at the the orthogonal vector, how is that? So here, so notice that when you write the slope like this with this notation, you start here at 0, 0, 0, and you go out like so. Okay. So notice that these are all perpendicular. Perpendicular to the same plane. Okay. All right. So now, if I wanted to write the equation of this line, we'll wrap this up here. If I say RT, okay, then my slope would be 0, 1, 0 t plus. Okay. Now I can use any point I want, depending on which. Here, so like for example, I draw, say, a line through here, or here. All these would be this slope here. Okay. All right, those would be all parallel. So the question is, what point? It's a B, C. Would I want to use? Okay. So if I wanted to start from the very beginning, 0, 0, I could just say 0, 0, 0, and then have the equation of the line. Okay. All right, so that's just a summary of just hopefully understanding the difference between planes and lines and how you use the slopes. And so the next video is going to